Hi guys, so today we're going to move on to 1.5. We should be taking this right after the quiz to come back with some homework for Friday. So 1.5 is all about composition of functions. Truly, this is the only thing that we need to worry about in 1.5, so it's a relatively short section. This is it. So I want to start us off with kind of an example of something that you've learned about before, but it will help us in remembering how to do composition of functions. So I want us to find f of 2 using the function f of x equals 2x squared minus x plus 1. And truly, I don't need these parentheses here. I'm going to shorten this up a little bit, just to make sure that this is something that you're going to see like in the book. So when I'm looking at this, when I do substitution in this form, when I'm composing, anything that should have been where this f of x was, okay? So I'm taking f of 2. That basically says any place there should have been x in my original function, I'm going to replace it with the number that I'm given. Okay, it could even be another variable, a negative, anything, but whatever it is, I'm replacing that x and that x with what's inside of this parentheses. One of the biggest things to remember is that everything else stays the same. So while my x's will change, my 2 and my squared will remain, this negative will remain, and this plus 1 will remain. Okay, I can't change anything about it unless it has an x to do with it. So when I'm rewriting this, it will be f of 2. And again, replacing every x with a 2. Oh, of course I wrote x because I said it. So instead of x, I put a 2. I put these parentheses in here because now that there's a value and not a variable, I need to break this up by parentheses so I know my order of operations. My squared still goes on top of it. I'm subtracting my 2 instead of my x, and continuing to add on my 1. So we can even backtrack this a step, and sometimes people get confused, and I say, well, write out the entire function, but leave a blank spot where the x should have been. Okay, so we've left that blank spot. Now, anywhere I have my blank spot, I go and put in my 2. So you can do it right away. You can write out this kind of template to then go put in your values, whatever works best for you, honestly. Okay, so now I need to solve this. We always deal with exponents first. So this is 2 squared. 2 squared is 4. So it's 2 times 4 minus 2 plus 1. 2 times 4 is 8 minus 2 plus 1. We add this up, 8 minus 2 is 6, plus 1 is 7. Okay, so whenever you're composing functions like this, when you're replacing the x variable with an actual value, you should come down to a nice clean actual value here at the end. So now when we move on to actual compositions of functions, the idea kind of stays the same. And that's why we practice a substitution method first. Because when people start to do actual, gosh, it's like flashing. When people start to do actual compositions of functions, it's like they lost everything they knew about simple substitution like that. So when we're looking at compositions, this could be written either as f, and we have this little o here in the middle, of g of x. Okay, or we can also have the opposite version of it, where we take g of f of x. Okay, so now when you're composing these, what happens is we're taking this f function as like our starting function. Okay, so that's the one that's starting way out here. So now, instead of replacing the x with a value like 2 in the last equation, I'm replacing f with an actual other function. Okay, I'm not taking f of 2 or f of 5, I'm taking f of g of x. So I'm replacing every x in that function with an entirely new function. Same thing with this way. Now with g being my first, I'm sorry, I don't know why it's like flashing like this. It's super weird. Okay. Nope, I did not fix it. Only when I move. Okay, so now since g is first, I'm starting with g and I'm replacing it with my function f of x. So it looks a little bit confusing at first. I just want you to be aware, the book generally uses this notation. I like to use this notation, so in notes I'll generally put it this way. But if you go look in the book, you're gonna see it written as this like fog or goth instead. The tiny little O in between those. So let's do an actual example. I'm gonna give you two functions. I'm gonna give you f of x. And for this example, that's going to equal x squared. And I'm going to give you g of x. In this example, that is x minus 1. Okay. What I want us to do is find, let's do g of x first. Okay. So again, you can use that kind of template method basically that I described in the last time. It gets a little messy sometimes because you don't know how much room to account for, but some people like to use it that way. And where I write down my whole g of x function because that's the function that I'm starting with, okay? So I write it nice and big because I'm gonna have to replace some stuff. So that's my g of x function. Now, when I take the composition, I replace every x in this function with my f of x function, since f of x is inside the parentheses. Okay, so I'm going to erase this x, that goes away. I put in my entire g of x function, which is x squared. So that's my final answer. Okay, let's do one that's a little bit more tricky. Let's try, I like this one. F of x equals x plus 2. G of x equals 4 minus x squared. Now I want us to find f of g of x. Okay, so pay really close attention to which one's coming first and which one's coming second. I don't know why this keeps flashing, but it's really bothering me. Let me try turning the light off. Okay, I may have to get back to look at that because that's really annoying. So when I'm now taking f of g of x, I'm starting with my f of x function, okay? That's this function up here. So every time I see an x, like right there, I replace it with the entire g of x function. So what this would look like is there's no longer an x. I put the whole g of x function, and I like to put it in parentheses if it's more than one term. And now I continue on with my original f of x function by adding 2. But I don't like to just stop right there because that's a pretty messy function that I can clean up a little bit. So this is 4 minus x squared plus 2. Add my like terms together. That's going to be 6 minus x squared. And that would be my final answer here. Okay, so now what if I went the opposite way? Let's say, okay, I'm good with f of g of x. I want to go back now and find g of f of x. So we start with g of x. That's our original function, okay? So I'm gonna write this function out until I hit an x. So I start with 4 minus, I hit an x. So now instead of x, I put in this whole function, x plus 2. Close it, and now I continue on with my g of x. The only thing left is this squared. Okay, that's the only thing left there. So generally, I like you to simplify these down, but for time's sake, I'm not gonna do this whole, distribution for you. So you can sometimes leave your answers like this, I get it. It's more about the process of making sure the composition is there and less about you being able to simplify this. Okay, I think that's enough examples. We're gonna do one at the start of class, just as like a little catch-up thing. Make sure we're all on the same page, make sure you actually hear me saying it. But bring any questions you have to class, and any remote learners, make sure you're emailing me with any questions. Okay, thank you.